hello. Just doing a quick sound check. I think we could go a little bit more than that. Test, test. That'll probably do. Okay, so that's too much. All right, so hi. Great. Yep. Sounds good. Welcome, everyone. Nice to see you. Nice to have you here. I think that at this stage, it looks like just because of how some commitments of mine have shaped up, the week 10 lecture will be probably online, I imagine at this point. The Monday one, the one I'm looking after. So today's our last day together for the term. Ain't that exciting? Before we start, this is a record crowd today. Apparently a lot of people want to listen to iteration 3. Good news is we're talking about that in the second half, sadly, so you got to put up with some stuff first. But first, did you know that this is the room on 50% lighting? I think it's the brightest lecture room on campus. If I turn the lighting up to full, it's something quite special, isn't it? It's an extremely bright room. I always walk in thinking the lights are on, but they weren't on. This is like what it was before. So, totally irrelevant fact for you all today. Yeah, cool. So I do have the Slido up here and the YouTube comments so we can track those as well. I will take that off the screen after about 5 minutes. So if you'd like to ask any questions during the lecture, just write down the Slido number so that you can ask some questions. But this lecture shouldn't take too long. We should be able to get through it before the halftime point because there's not a lot to it. It's quite conceptually straightforward, no pun intended, but let's get into it. So conceptual modeling. This was a topic introduced years ago by another lecturer, which is really interesting and kind of touched on the fact that like one thing you don't actually do a lot throughout your CS degree is model stuff, you know. We'll kind of unpack more of that in a bit, but it's one of those things where the amount of time you might spend out in the big bad world writing code versus planning code is a little bit skewed at university, right? Like quite often we're like, let's just go in and do stuff. Let's just quickly make it happen. And even more than that, sometimes we actually will be writing code as programmers to model things out there in the real world. But we don't talk about that a lot because as far as I know, there's a remarkably small amount of programming that ever happens at uni for modeling, right? Like uni would generally have a bias skew towards like games and little apps and things. Like how many kind of games or little apps have you ever had at uni that you build, right? Like you go back to your first year courses. There's quite a lot. And we do that often because games get students interested and excited, but reality is the amount of gaming per course time you do at uni for most people is like 99% of people is like well in excess of what you'll touch out there once you leave uni. So it is important that we cover some other interesting topics. So, just get that off. What is a model? Any ideas? Someone who doesn't know the lecture, no ideas? Okay, that's good. Someone very firmly said no ideas. If you had to describe it, how would you describe it? I'll punish you for sitting up the front.
A way of just representing an idea.
A way of representing an idea. That's a good one. What's an example of a model in that sense to you when you think of a model?
Like a model of an atom.
Model of an atom. That's great. You're going to see that appear as one of our examples. There's lots of different examples of what a model can be to people, right? A lot of the more kind of social ones you'll see are like, oh, it's a model ship or a model plane or a model car, right? Everyone's probably seen those before. You have things like mathematical models. Someone can go and, you'll hear some mathematician is like, yeah, you watch those space movies, like what was that great one with the women and NASA? Came out a few years ago. Sorry? Hidden Figures. Yeah. So like Hidden Figures, right? Like they're doing a lot of mathematical modeling. They're representing an idea of what it's like for a spaceship to go through space and how fast it needs to go and what angle. You have things like actual models, which is probably the least model-y model in the sense that we're talking at this point. But they are often still representing an idea, right? Themselves, or at least the model is. We won't go there. You have diagrams. You don't really think about this too much, but a diagram is a form of a model. It's a form of representing an idea, you know? Like, why do we draw diagrams instead of doing the real thing? Because if you think about most diagrams you draw, they literally exist in like spite of the actual thing itself. You know, like, you think about every time you've drawn a diagram, it's to explain something to someone who you can't just give the thing to. Like if I was to give you a diagram of how a car works, it's because you aren't capable enough for me to just give you a car and for you to figure it all out. You need like a representation of that car. So quite often drawings and diagrams are a big part of that. Adam, there's your Adam friend there. Same in science, we do this a lot with science. One of the models for some reason that I think about a lot whenever I think about this topic is like the climate change models and all the greenhouse stuff, you know, where they're like, these are charts and this is what's going to happen in the future. Because you can imagine to understand the world and what's happening with temperatures and seas and all this other BS going on around, you know, what's going on with the climate, you can't really just like understand it without representing it in a somewhat simpler way. So lots and lots of different things. So models are simplified representation. I think one of the critical things there is simplified. To assist in understanding something more complicated, right? So without a model, all we have in life is to actually understand the thing, which is typically more complicated than the model, which is the simplified version of the thing. And that word and that kind of terminology is great because it applies to like basically like so much stuff that you've probably interacted with before and will interact with. Now, that was modeling. We had examples there of mathematics and we had examples there of model ships in little water bottles or whatever. Has anyone ever made a little model ship in a water bottle? You have? Oh. How was that? That sounds like a very... Does it teach you patience? Yeah? I feel like is that the thing where you literally get the tweezers and... So you actually do that thing where you get the tweezers and you... Damn, there you go. Well, you probably got more patience than me. I'd probably throw the thing at the wall after a few hours. So we have things like that, the model ship, right? But that's a whole subset of modeling over here that we might call, you know, physical modeling. The other type of modeling that we're talking about is what we would call conceptual modeling, which is, you know, the title of this movie today. And it's a model that captures a system in a way that's conceptual other than physical. Wow, surprise, surprise. Most physical models are typically simplifications of the real thing, either in terms of removing the inner workings of stuff or by making them smaller, you know? So if you want to make like a model, you know, plane's really big, so you might make a really small one that people could like kind of see and walk around and understand. And it's cheaper as a big part of physical models too. Or you might make something like a Formula 1 car or a race car, which is normally really expensive, but if you can just make the outside of the car because the insides aren't necessary to understand it, then you've again simplified the thing to make it more understandable. Conceptual modeling, though, is pretty much everything else around drawings, diagrams, mathematics, computing. They're basically just things you can't touch, which is pretty straightforward. And usually they tend to be diagrammatic or visual, though they can often still be quite mathematical in nature as well. So examples of these might be like the math models we mentioned before, data models. So whenever there's a complicated system out there, you can usually model your data in some way. A lot of the time, data will be modeled these days through what we call entity relation diagrams. These, in theory, shouldn't come up too much in your degree unless you actually go and do a databases course, which is really what this relates to, which is where you could describe an entire database in terms of like, you know, different aspects of it and different properties of it. You could actually do this for your data store if you really wanted to. You know, use a model like a data model just to represent it. And the thing about conceptual models is that they don't always have to be diagrammatic. So these are diagrammatic, and diagrammatic models are quite popular because they're very, humans like seeing stuff. You know, we don't do well when we can't see something. But you could see your data.md that you did back in iteration 0 as a form of a model too. You are modeling the data in a sense, in a very simplified way that you were going to end up creating later on, which kind of gets into where a lot of modeling can relate to planning as well. We have domain models. They're a bit more complicated to explain with the kind of software you've done to date, but you will actually touch on those in COMP1511 when you go and study that after this course. So, coming soon, I guess. And then the state transition models, which we will actually talk about today, and they're really interesting models, and we actually go a bit deeper into this one specifically because it's fun and it lends itself well to how things, lends itself well to keeping you engaged with the topic, I should say. And that's when we model how a program operates at different stages, because there's a lot of software out there, a large amount of software that basically moves between different states. This is overrepresented typically in the world of robotics, naturally, but it can kind of happen anywhere, right? Like you could model, say like a chatbot. I had to talk to Airbnb this morning on the chat, right? And it's like how a chatbot piece of software could work. You could model it really simply between two states, which is preparing a response and waiting for a response, Like the software just oscillates between that, like all these digital chatbots. Or you could break that up further and say, reading the response and thinking about the response and preparing the response and writing the response and then waiting for the user to respond again. And you know what I mean? Like you could draw that if I asked you to draw it. That's what a state transition model is. It's a type of model that just represents how software moves between different phases, which again, quite powerful. So when we think about these conceptual models, they are typically broken up into one of two types. There's either structural stuff or there's behavioral stuff. Now, structural stuff is static things. They represent like just how software is. It's nearly like a schematic. Like you think about a blueprint for a house, that's just the house. You don't really understand, what happens, like doesn't show you how people move through the house or anything. It just shows you the structure of it. So examples like the UML, the COMP1511 diagrams, as well as the database diagrams, they generally are static ones. Whereas behavioral diagrams are a bit more dynamic and they show you actually how software changes. So behavioral is like how it's used, how it morphs over time. There's a time element to that, whereas there's no time element to structural. Another type of conceptual model that you do talk about is use case diagrams. Yu-Chao will be doing that next week when talking about requirements, which is that part one of the software development lifecycle. Yu-Chao's covering that next week. So hold tight for that one, but we will be talking about these state diagrams or these state transition models more and more today. Now, last kind of little bit of academic thinking here. Models can be used for, I think the second point and the fourth point are kind of repeating themselves, but generally speaking, they're used for one of three things. They're used to understand the past, or they're used to understand the future, or they're used to simplify the present. And I find that the whole past and future things are kind of often in a basket over here, and then the manage the present ones are over here, because quite often a good example is how does money move between Australia and the US, right? Like economically, I don't know. I would be able to tell you very little about that, except I'm sure we sell stuff to them and they sell stuff to us. So without trying to predict the future or understand the past, you could sit down with people and try to create a conceptual model of what that is, and that might involve doing some research, and you think, okay, well, Australians send money over to the US every day and people send money back. I have friends that work at Google. They get paid by Google in stock, right? And that stock appears in a US bank account because it's an American company, and then they have to send it back. Okay, cool. Well, there's an element of it. There's the trade element when we sell products, buy products. There'd be a whole bunch of stuff, and you could sit down and model it in a really simplified way. Maybe you could draw a nice little diagram of it. You know what? Infographics are basically just models, if you think about it. Infographics are just simple ways to understand a lot of stuff. But the other types of models I find that are kind of in their own interesting basket are ones that take information about our understanding of the world and try and look back, or they try and look forward. And the ones that try and look back are the ones where they say, let's, those things where they're like, what did all the continents millions of years ago? This whole thing, how they're like, the world used to be joined together. Is that news to anyone? Surprise or something? I don't know. I think you all know that. But they figured this out at some point, and you've probably seen the animations of it. And yeah, maybe they hand animated that, I don't know. But they also could have figured out, well, where are all those tectonic plates and whatnot, and they probably could have figured it out mathematically and been like, which way is this drifting, and then actually write a model that would be able to kind of go back in time and apply the same rules and move something together. And similarly, they can do the same thing. Who's ever seen all that? They're like years ago, like 20 years ago when I was in high school, they were like, New York's going to be underwater by like 2012 because of like climate change and stuff. That's not me getting into I don't have a view on that. That's not me being like, climate change isn't real. It's just like someone made that diagram is the point. Someone modeled it, Someone had to figure out how to understand the world and then be like, let's slide that time thing forward. The reason this should be interesting, and the reason this should be interesting to you is a lot of these models that look backwards and look forwards when it comes to modeling, they are typically heavily involved. There's heavy involvement by software engineers like yourselves, because these things are often programmed, Like they didn't hand a whole bunch of information about sea levels and stuff to an artist and said, can you make that? There was a process in the middle there where someone technical had to get involved to actually figure that out and actually model New York City, right? Because there'd be a model somewhere of New York City where they could tell you every square meter, how high is that off the ground? Maybe down to the nearest 10 centimeters. In reality, it's a lot more complicated, but it's a model. It's a simplification of New York City. So they're like, yep, every piece of the ground's like here or here or here or here, and then we apply water, and then the sea levels rise by this, and then what goes on. So that's why I kind of bucket the kind of past and future into a certain area, because it's quite often writing software and then just applying time to it. Whereas the simplification parts, like understanding the present state of affairs, I find that's where a lot more of the diagrammatic stuff comes in. Because quite often what we're spending time doing is just trying to draw and be like, okay, this is complicated, let me explain it to you. And I have to do that all the time. Like as an example, I wonder if I can show you. I don't know if I'm logged in right now, but as an example, we recently had to, at work, we had to go and redesign a whole big chunk of and how an entire user might say set up, the system. They like join a platform, right? Like sign up to Netflix and use it, kind of thing. And before we went and built it, we went and like had to draw this out, right? And there's a lot of stuff here. This is one of my engineers who's probably working at the moment, having fun. I don't know what they're up to, but the details don't really matter, but the point is that this is, I think, a good example of like understanding the current state of affairs in terms of a model. It's a big file, right? This took like 4 or 5 days for one person to try and create, but this was critical because what we're trying to do is so complicated that you could not ever get anyone to understand it who isn't fully immersed in it. Whereas this allows like 5 or 6 people who only half understand it to be like, great, I understand the abstraction of it. I think you get what a diagram is, right? So I don't want to kind of beat that to death and you're like, what did you learn today? It's like Hayden said that diagrams are really useful to understand stuff, and someone's like, great, that sounds like you're spending your university dollars really well. Does anyone think about the hex debt? No? How much does a course cost these days? Is it like, it's like $1,500 for this course? Yeah, what I always thought about is like, let's say you do 8 courses a year, 1,500 times 8. So like that's your bill every year. And then I was like, how many days do you study a year? Well, it's like probably, I don't know, call like 40 weeks of the year. So I was like, okay, then you divide that by 40, and then you divide that by 5 days a week, maybe 6, whatever, or 7. Let's pretend you're working 7 days a week. I was like, man, isn't it funny how like hex hides away debt? Because like if I said to you every day, for the next 4 years, for the privilege of learning here, you had to pull 2 $20 notes out of your pocket and throw it at the university, I reckon everyone would think wildly different. I reckon the government should pay out your hex in cash, and then you have to like hand it in every day when you come to campus. Because I reckon if people had to hand in that amount of cash every day, every single person, including myself, would work way harder than you do at uni, because you'd be like, oh my God, that's a lot of money disappearing. That was just some levity interjections. Don't stress about that. Back to our regular programming. Communicating models, I don't really want to say much on here because I kind of just unpacked it and you can read that as well. We're going to get into state diagrams now. So we've just spent the last little while talking about modeling generally, inspiring you about its value. Now we're going to dig into one type of conceptual model, or specifically one type of behavioral conceptual model, which is state diagrams, which represent a state. We referred to these as state transition models before, but more colloquially they're referred to as state diagrams, or sometimes state machines, or quite often I guess you would say a state diagram describes a state machine. So you have a piece of software. If the software clearly moves between different states, like a chatbot, then that piece of software is what we would call a state machine. And a state diagram would represent that state machine. It is a model for a state machine. And this is a state diagram or state model for a door, right? So the door is either open or closed. And you can move it from open to closed by closing it, and you can move it from closed to open by opening it. Surprise. But that's how you'd represent it. And a lot of these state diagrams are represented as circles to denote this is a particular state, and lines to say this is how we move between them. And as an example, this is one we often talk to students with. This is a state diagram for a parking meter. So let's imagine, again, we're making a parking meter. Okay. Someone doesn't know how it works. You know, maybe the council needs to know how it works. People on the helpline, right? Like you call up the local council and you say the parking meter's not working. Like they're not going to know the intricacies of how it works. They haven't sat down and like just put money in it for like an hour and played around with all the combinations, right? So to model that and make it more digestible, we make something like this, which says, well, when you come to the parking meter, we're in the first state, which is the enter parking bay state, where we're waiting for a parking bay number. This is one of those ones where you punch in like what spot you're in, like spot 63, and then you pay it money. And then what happens is, and there's only one thing you can do from here, which is input a number. So this diagram helps us understand that from that first screen, the only thing you can do is input a number to get to another step. That next step is then enter how long you want to stay for, 1 hour, 2 hour, 3 hour, 4 hour. And from here, we can see the only things they can do from there are also input more numbers, or they can cancel. And if you cancel, you go back to the start. Sure, you enter a number, you insert coins. We've got this little self-referring one here, an edge to the same node, if you will, where it's like you keep inserting more coins. And then once you've inserted enough coins, there's sufficient funds. And then you get to a confirm screen where if you say OK, it takes you right back to the start. And if you say cancel, the coins are ejected and you go back to the start too. That's a state diagram. Does anyone find any issues with this diagram or something that irks them about it? I could think of 3 or 4 things. So I'd like your thoughts on it too. But I've been looking at this for a long time as well. Seems pretty good.
I haven't gone through it. Like when I first looked at it, I had no idea what I was looking at. But like, having gone through it step by step, I'm like, yeah, no, that.
Wow, the model did its job. It's exciting. Yep. Yeah. So it never dispenses the ticket. That's one. Yes, that's not really clear on the diagram at all. Here's another one for you that I often think about. And this gets to a really important question to do with models in general. From confirm, when I hit cancel, it just says cancel coins ejected here. If you think about the lines are often denoting actions, right? Coins ejected might not be an action from a user. It depends how you're thinking about this diagram. Wouldn't it make more sense to say when someone goes from confirm, they hit cancel, which takes them to an ejecting coin state. And then from the ejecting coin state, there's like another thing back to the start that says like finished ejecting coins, you know? Is that better? Maybe. And this is actually where I guess you'd say the art of modeling comes in, is that idea I just mentioned where it's like, shouldn't there be another circle? How far do you take that? At what point do you stop drawing circles? Because you could keep drawing circles. You could keep thinking of edge cases. You could think, oh, what happens if the power's cut to the parking bay? You know, because these things run on power, whether it's like a solar panel or whether it's like from, you know, the grid. And then you think, you know, well, what happens if a user does this, or what happens if a user does that? And I reckon if you tried, you could make this model about 3 or 4 times more complicated. And this is the reason I mention that is because the difficulty of this stuff is rarely drawing something in your head, because we can all draw. It's understanding how it's being used or who it's being used for, and where the line is between clarity and chaos. Because too simple and people don't actually understand the nuance of the system. Too complicated and people can't understand how the system works in a nutshell. So like we have another diagram down here where we decided to add another requirement in, which exists, which I'm sure a lot of you probably weren't even thinking about, which is that at some point, if you enter your parking bay and you enter a number, and then you just do nothing, it's not just going to sit there for hours, right? It's eventually going to be like, I think this person's walked away now after a few minutes, and it's going to cancel itself and go back to the start. Who's ordered McDonald's from the screens? Who's ever sat at the McDonald's screen thinking too long about what you're trying to buy? And it's like, are you still there? Because we're about to cancel your order because we've got other people who want McDonald's, and this is true for any of those similar systems. How do you represent that in a state diagram? And then some stuff gets really hard to represent. Like you think, okay, if they canceled or 5 minutes elapses, that actually makes sense. But is it better to write it like that, or is it better to write it as a cancel line and then you write another line that's like 5 minutes has elapsed, Does the complexity of kind of adding a few different lines, is that bad, or is the complexity of trying to write bloody like or statements into an action, is that more confusing? Don't know. And again, you just like you'll learn this stuff passively as you draw more. There's not really like a clear science to it. It's just like any form of communication. It's like, how do you send a message to someone without seeming too mean or angry? It's the same thing, right? Like you can follow rules and you can Google it and read some BuzzFeed article about top 10 ways to not sound too angry, but at the end of the day, you're only really going to learn by doing. I used to do this activity a lot, though I think this might be one of the first terms I don't know. I have mixed feelings about it. I just don't know if I like modeling the Opal. When I say Opal, it's like Sydney transport system, and you tap on and tap off. Does anyone have a system out there they think is interesting that they think might be a state machine that they want us to try and draw? That'd be fun. But I need ideas from you. Could be anything, yeah. Course enrollment. I haven't done that in a long time, so I might need your help. But yes, I think that would be a good example. I mean, you can actually model a lot of the web pages. I'm just going to do this stuff I'll just do this stuff in the same tool that I was showing you before. The cool thing about modeling is you can use a whole bunch of stuff, and a lot of it's free. Miro is a great application, but we pay for it for work. Like this is my work account here, so I'm just making some random thing on a work account. Figma is really popular. Canva can do, like there's so many applications now you can draw stuff in. There's no real kind of gold standard. There's the old, my old favorite website that got me through most of my life was this app.diagrams.net website. I don't know why I like it so much. It's just so dumb and simple. It's like, oh, I've got a box and then I've got another box, and it's all free and it works. So that's nostalgic for me. But again, I could list another 5 of these types of products. So if we were to say draw a course enrollment system, now I'm just going to make some assumptions here. I mean, how does it work? Let's do this. Describe it to me.
So about 3 weeks before enrollment date, I assume something is pushed at timetables.
Yeah.
You get an email saying timetables are released, and this is when your enrollment slot is, which is a certain day.
Yeah. You search for a course.
So your course selection is done before that. So there's kind of 2 stages. Course selection and one's class enrollment.
So you select your course, and then once your enrollment date opens, that's when you can pick your classes in that course. Right. How does this is just me asking questions now. How does the waitlist work then? Does that happen? Yeah, has anyone been put on a waitlist yet?
Yeah.
Does that happen before you select your course? Do you select your course and they're you're kind of not yet in it?
You select your course and then your timetable slots, and then it will tell you if you need to be on a wait list or not.
Oh, yeah, not something. Yeah. It's all right. Yeah, okay. But so I mean, and what I like about that example you've given is that, then we think, how do we draw that? And the worst thing we could do is just draw it. The best thing we could do is try and figure out, not that you'll have an answer to it, but why are we drawing it, right? And there's a few different answers. We could say, well, I'm drawing it so that the people at UNSW who work internally understand when the timetable's up, and we could draw like the timetable not loaded, timetable loaded part. Or we could do it from the perspective of a student, right? Which, is another one, because students don't know when some of this happens. And I mean, this is going to be a relatively straightforward one, but you said there was like the whole like, can you pick your courses anytime? Yeah.
Yeah, so like I picked all of mine for the year at the beginning of the year, and then but I only get to actually choose my timetable.
Yeah, and this is what's cool about this example is some of this stuff's hard to represent, and usually like if I'm just like, okay, well, there's like I start off by waiting for next year. So let's imagine that it's like December 30 and I finished up for T3. That's kind of my initial state. Okay, well, what am I going to do then? At some point, it's going to be like ready to choose courses for the whole year, right? And then, well, how do I move between those two states? Well, I let the new year come to me, and there's the new year. And then after I've chosen courses for the whole year, you're in what you could say I'm in a state of waiting to be told when I can enroll. Yeah. So once you've chosen your courses, then you're like waiting for the next term's enrollment date to be told to me, say. Not very succinct of me, but that will do. And then here, well, what's going to happen is that after we've chosen our courses, we're now just waiting. Well, yeah, sorry, ready to choose courses, chosen courses. So then we wait for the next term's enrollment date to be told, and then what happens is they tell you the enrollment date, and then you like wait for the exact date. So you go, yep, they told me enrollment date. And then whilst you wait for the exact date, eventually the date, I'm just drawing this down now, the date arrives and you choose courses for you've already chosen courses. You choose timetable slots for each course. And again, I'm probably going to butcher a few things there. Once you've done that, what you do then is you wait for the next term's enrollment date to be told to you, because you've done everything for T1, so now you're just waiting for T2. And it's like, what's interesting, and I like kind of these fresh examples work well, because I'm sure as I'm doing that, a few of you are going a few steps ahead, and what I did might be slightly different, for better or for worse. I might have like cut out a step or added a step. Some of you might be thinking about, yeah, sure, but this kind of just sends you in an infinite loop and you never actually like end up waiting for the next year again, So then it's like, well, once you've chosen timetables for each course, you kind of might then need another one that says like, if it's T3, and this one's like, if it's T1 or T2, because like if it is T3, then you just kind of wait for the next year. Because what I had before with this will just be like infinite terms forever, and you'll never actually get to a new year where you select the whole new courses for the year again. It sounds really complicated, by the way. I think when I was at uni, they were just like, oh, the next term's coming up. Pick your courses and timetable next week, and that was like it. Yeah, I know they still staggered it. I remember that, but it's so interesting how you pick all your courses at the start of the year. I guess that makes sense, actually, because then you can kind of plan out your program a bit. Progress. So you might have something like that. Some people might think, hey, this process is a bit redundant. Like we don't really need to be like, there's a point in time where we're told what the dates are, and then there's a point in time where we could select it. We could just have something that says, okay, once you've chosen the courses, you then are just like waiting to be able to choose your timetable. So you could collapse these two things down into one step, which again, why this is so finicky is because should you collapse it down into one step? Depends what you're trying to achieve. I wrote this in a way that I'm trying to help people understand the psychology of what it's like being a student, because as a student, you do actually like really think about, okay, I have no idea when I can pick. And then once you can pick, it's in the calendar and you're like thinking about it, and you're planning for it. But if that's not the goal, if the goal isn't to kind of get into the deeper psychology of the student, and it's actually just to show them practically what you can do, then you could probably simplify this further. And again, you could probably make this more complicated. You could definitely make this choose timetable slot for each course. more drawn out if you'd like to. Again, I just kind of modeled that in my head as like, well, they sit down for an hour and do it. But if you're trying to actually explain how the software works a bit more for the student, you might be like, choosing course, chooses course, chooses, picks course, because picks course of their selection. And then it's like selects time for class until like you've selected all your times for your class. Then you go back to the next course and you do that again until you've done all the courses, and then you leave it. Like I could blow this step out into something significantly bigger if I wanted to, which again depends on what I'm trying to achieve. It's actually quite a fun topic, and I don't think I've said this yet because Chad did the design lecture, but these topics around design and conceptual modeling, why you should care, even though they kind of feel like academic filler, is just because, I say this every term, it's like your capacity to program is fairly meaningless to the workforce, right? Companies are rapidly figuring out how to use AI. They're rapidly figuring out how to offshore development to people that are cheaper than you, right? Because you want to work for more than like $20 an hour, I'm sure, in 10 years. And as they do that, to what extent is a very open-ended question. But the way you will always, most likely, at least most of you, will continue to stand out in your professional careers is less about your capacity to write code, and it's more about your capacity to do stuff like this, because I'm sure will get to a point where you will be able to, actually a really good example for you. Let's say right now ChatGPT can write a lot of code. Sure. Where people like you and I will continue to try and be important is hearing someone talk about the software they want and understanding exactly how to translate that, either visually or in text, into something that an AI model will understand well what to write, And I can give you a lot of different examples. UChad's design stuff is also important because, well-designed software is a hard thing to get right, and generally what you find is like, whilst you can get cheap software out there or quick software like ChatGPT, it is hard to have it understand the exact problem you're trying to solve and the degree to which you should complicate it or overcomplicate it. So that was me trying to unpack a very big idea in a very small amount of space. But the point is, don't poo-poo this stuff because, I bet you that, the people who are earning more at, people who are earning, like, there's people in software who are writing code, and then I reckon the people who are earning way more than the people in software writing code are probably often the people who can draw stuff like this really quickly that explains stuff to everyone and really succinctly and gives it to their team and says, like, this is what we're going to do. Sometimes you often hear this referred to as architecture in the world of software, because software architecture is quite literally just software modeling. You are just trying to, like, simplify the overall, this piece and that piece and this piece, how it all fits together, often diagrammatically. And people who are good architects, again, do very well professionally because that's hard to get right, and if you get it wrong, it's very costly. And you need a lot of experience to get it right. So, continue to consider this kind of stuff important. Again, I know it's not going to come up much at uni, realistically. There's just not enough you do where you'll see much of this. But let's say for a lot of you are going to get your first job at some point and someone wants you to solve a problem. They're like, we need to have this feature added, and it's a non-trivial thing. Just whip out a diagram tool and try and quickly model your understanding of it. It'll go a long way. It'll save you time, everyone else time, and they'll probably be a little bit impressed with you. The very last thing before we wrap up this part of the lecture is I always worry that when we talk about conceptual modeling, we run the risk of giving the impression that it's all about drawing. It's a little art activity, diagrams and stuff. But a lot of modeling is done in code and spreadsheets and stuff. A really common thing that a lot of people do, maybe a little less directly in software, will be modeling, say like, okay, here's a good example. You're running the School of Computer Science and they tell you that the number of students we have enrolling is growing by 10% a year. Can we afford that, right? I don't know, can we afford that? So what you do is you open up an Excel spreadsheet and you go and put in the number of students we have, and you write some formulas, and the number of students grows, and you put in the number of staff, and the average staff can teach this, but blah, blah, blah. And eventually you make a big Excel spreadsheet that kind of shows you the future. So back to these models where I said we're like looking at the past or predicting the future, a lot of those types of models, we will need to actually use tools like Python, JavaScript, or Excel to go and model those things. You'd actually be amazed how often some people can end up using Google Sheets a lot as like professional engineers. Because like at the end of the day, there's a lot of things sometimes you might need to model or predict or analyze. And you can do it in like Python or JavaScript, but it's actually just quicker to do it in Sheets and things if it's like not too complicated. But I really like this example because, so back in 2015, when I was like running the solar car team here, you've probably seen the car on campus, the one near the front of campus, near the law building. So we were racing across the country like this. We were driving from Darwin to Adelaide, from top to bottom. It takes about 6 days to do. It's not super fast. I don't know if our car is going to come up here without me searching it, but there it is. We were basically racing this car from Darwin to Adelaide. This is the car we raced. Oh, sorry, no, that's their car. This is the recent car, the one from the last few years. But this is the car we raced back in 2015. And the thing was, and I love this example of conceptual modeling because you have this car, and it's a funny little activity because you have a battery pack in the car, you know, and you have to figure out how fast to go to get to Adelaide first. You know, so you start in Darwin and you got to get to Adelaide. And you're racing maybe like 20 other teams, and they've all got cars with batteries in it too. And the reason that's hard is because it's actually a lot like, has anyone ever ridden a bicycle or ran anywhere before? You know, who's ever run to the station? Anyone live like further than 10 minutes from a train station, have to run to the station? You know that feeling where you're like, if I sprint, I'm gonna die after about 100 meters, and then I'm barely gonna make it. You know, so you're like, I have to kind of like run, but not too quick, so that I can keep running. And then you're like, I'm really unfit, and anyway, negative spiral. But it's like, it's a similar thing with the car. It's just that like you can kind of figure out your running intuitively a lot of the time. But if I said to you, how fast should we drive so that we get to Adelaide, as quickly as possible in the next 6 days, where if we don't use enough of our energy, we're going to lose. And if we use too much of our energy, we're going to, you know, find ourselves 300 meters from Epping Station on the floor having like some kind of, you know, lung attack going on, asthma attack. And then, you know, you just like can't drive anymore, and everyone overtakes you while you pulled over on the side of the road. So what a guy called Tom in our solar car team did was he actually used a whole bunch of previous research, which it was written by a really talented woman called Alex a while ago now. Gernot is really quite a significant figure in CSE, does a lot of stuff with low-level systems, but they basically, Alex wrote a kind of a thesis about, I think this was an undergraduate thesis, I can't remember. It is quite big actually. Seems a bit too small for something. Anyway, I don't know what it was, but it was a thesis of some sort that was like, how does a car use energy, you know, and how much, like what goes on. So he took that and tried to model it. And this is something that other people have tried to do before, where how do you solve a problem that big, you know? So what he did was he basically said, well, okay, from Darwin to Adelaide we have 3,000 kilometers. Okay, let's break that up into, that's 3 million meters, you know? Let's break that up into 100-meter chunks, you know? Like, let's say from here to here is 100 meters. And that gives you 30,000 chunks. So there's 30,000 segments of the journey from Darwin to Adelaide. And then for each of those chunks, what we're going to do is we are going to find a fixed wind speed, what we think the wind will be at that point. That's something you need to kind of work with, like bomb data or weather zone data or something, because they can give you predictions of that. So you've got to find that information. We're going to assume there's a certain amount of angle of the road, elevation, right? Because if you're driving up, you're going to use more power, and if you're driving down, you're going to use less. We're going to figure out what orientation the road is to north, because cars like this, their solar panels aren't flat. So like, depending on the angle of the car, the sun's going to be hitting it differently. We're going to assume that there's a certain amount of like sunlight you're getting from that moment, which is also based on weather data. We're going to assume there's certain, I mentioned wind at the start already. Yeah. With wind, it's going to come from a direction as well, not just a strength. And we're also going to look at like the weight of the car and all these other things. And then what you have to do, and this is kind of where mathematics and software often come together, is figure out, okay, if I gave you a certain wind direction and wind speed and elevation and this and that and this, how much energy would that car use for 100 meters? Now the cool thing is that's actually a much easier problem to solve, right? Like if I just said, here's a vehicle, you do some study on it, you realize the motors are 90% efficient, it's got this much aerodynamic drag, mathematics, trigonometry, the sun hits the solar panels at this, they've got a 20% efficiency. Like you get deeper into it, it's not a quick thing to solve, but you can eventually get to a point where you could write yourself a JavaScript function that takes in all those inputs and spits out the amount of energy that's used, or an ideal speed, the amount of energy that's used for that little 100-meter segment, right? And then you just repeat that for all the 100-meter segments, and what you find out with at the end is the total amount of energy used. And then you're like, okay, great, well now we can figure out if we've gone too fast. Because you imagine if you've got like, say, 100 liters of electricity, not that that's how you think about it, if you've got 100 liters of electricity in your car, and then you punch in a speed of 60 kilometers an hour into your JavaScript function, and it says you need 102 liters of electricity to do that, then you're just going to reduce your speed from 60 to 59 and run it again, That's just kind of how the software was written. And you could write it a whole bunch of different ways, and we had to rewrite it in 2017 to be something very different. But I always thought this was a really cool example about how you model car stuff, because if anyone's ever been in an electric car, or actually any car these days really, it tells you how long you've got left to drive on like petrol cars. It has like a little picture of the petrol station and then a number. It's like 600 kilometers till you have to fill up again. Or in electric cars, they give you the distance as well. You bet they're doing that because they're not going to know perfectly what's going on. In fact, their situation's worse because they don't know what the hell you're going to do with the car, They don't know if you're going to drive it up a hill for like 6 hours straight or try to. They don't know if you're going to be going down the highway or driving like a lunatic through the city. So they have an even a bigger problem to model than anyone. But let's say that, these new Teslas, you say, I'm going to drive to Melbourne. In theory, they could look at all the information to do with the weather and everything else and what the wind's doing if they wanted to and give you a really accurate description based on a model they write. But like all models, it's imperfect because everything's an estimate. Wind doesn't blow perfectly for 100 meters of road and then change slightly for another 100 meters of road, right? Like everything varies all the time. But that was a cool piece of software that was written. You probably don't have any questions about that, but if you do, it's a good time to ask. Did it work? Yeah, it worked. It's a hard thing to get right. I mean, like we learned this through 2 races, and it was my advice to the guys here, because the team here, when they did their race in 2023, they ran out of energy last year. And it's hard because like sometimes, particularly on the race itself, you want to rely on the models, but sometimes the models aren't super accurate. If that makes sense. The worst thing you can do is like if your model, it's like your model's error margin. If it's like big enough, then it's like really hard to rely on it at all. So quite often it was like really helpful with understanding generally what we should do. Like, okay, today we should probably do about 60. But then like you do 60 and you notice that you're using more energy than you should be. And at that point, it was like we wouldn't be sitting on a computer trying to figure that out in real time. It would be like we should probably just go 5 Ks an hour slower and see what happens. Because you can run into the problem of trying to over-engineer it on the day. But yeah, it was super useful in figuring out the gist of it, definitely. Because a lot of teams, and we had the same problem ourselves in 2017. We ran out of energy. We kind of ran out of energy too in 2017. So the 2023 race and the 2017 race ran out of energy. I think the 2019 race they didn't. They had like a big excess of it. So yeah, random facts. Cool stuff though. Driving solar cars, lots of fun. A lot of the people who did this stuff actually ended up at Tesla. A lot of Tesla's early engineers were doing this back in the 2000s. So there's a lot of weird overlap. I often tell people, has anyone seen those funny Tesla doors? Where they like, the like Model 3 doors? This is really unrelated to anything. Door handles, I should say. These ones where you like push and pull them out. Yeah, seen those. Like, I don't know if this is true, but what I always found funny is like, that's actually how like solar car doors have been designed for like since forever. is that because they're really aerodynamic, and like these cars, they have to be aerodynamic because like even a little door handle sticking out, it's like really bad. And I was like, and I started seeing it on Tesla, and I knew that like a lot of early Tesla engineers were from the solar car world, and I was like, oh, that makes sense because they had a lot of trouble with ranges in electric cars. I remember Elon at one point was trying to get rid of mirrors on the car, you know, like these little things here, side mirrors. Because I think he figured out it was like they use about 5% of the energy, just like trying to overcome the wind, because they like stick out and they're kind of an ugly thing. He's trying to lobby the US government, I think, to let him make cars without side mirrors so that he could like, you know, increase the car's range by 5% or something like that. That didn't happen, obviously. But yeah, we're getting well off topic now. So that's kind of it for conceptual modeling. Oh yeah, we did. Did I duplicate that? Doesn't matter. Okay. Let's take a quick 5-minute break just to stretch your legs before we talk about iteration 3. But otherwise, thank you. Hope that was interesting. Oh, someone did ask in the, real quick, someone asked in the chat, are we expected to draw a model or something like that in iteration 3? Yes, we'll get to that soon. Hello, welcome back. Welcome to the long-awaited Iteration 3 lecture, where I'm probably going to tell you less than you'd hope because there's actually not a significant amount to talk about. But nonetheless, here's what we're going to do. The spec, I rewrote this spec like 2 years ago to be structured a little bit nicer, such that when Iteration 3 came around, you only need to read the stuff with the duck. So every other section's the same. You know, we don't really need to go through this or individual contribution or leaderboard, just the duck section. So now we're going to talk about the duck. Okay, so I also did your Iteration 2 lecture this term for you, Chow. And in that lecture, I talked about how Iteration 2 had the biggest jump up effect. And Iteration 3 wasn't that big to jump, which is true. At the top of this one, if you remember this from Iteration 2, we also have this little bit of information here, which is saying that there's actually some routes now that are different. Now, the cool thing about this is that when we say they're different, what we actually mean, and I'm just going to jump straight to the Swagger, because a lot of you have probably spent a lot of time looking at the Swagger docs, is if I look at the Swagger, we have our Iteration 2 using Iteration 1, right? Is this traumatic for you to look at a little bit, maybe? Iteration 2 new. And then when we go further down, we've got new stuff now. Wow, look at that long list. But here's the cool part of it. The Iteration 3 routes are broken up into two sections, Iteration 3 modified and Iteration 3 new. The Iteration 3 modified routes, you notice something in particular about them, which is this little number 2 here. This little number 2 means that there's a second version of that route. The good news about that is it means that for all of these routes, you can largely copy and paste the code and make small modifications to it, right? So just like in Iteration 2, remember how Iteration 2 had the stuff that was like a little bit easier because you'd done the work on it, and then it had the stuff you had to do from scratch? Same thing here. All of this stuff in Iteration 3 modified, these are all routes you already have in Iteration 2. So don't be alarmed by the size of that list. The size of what the work looks like is probably inflated by like 5 times. However, this stuff is new. Wow, yay. Mostly what Iteration 3 pertains to in terms of the extra work is the creating of game sessions and the playability of those sessions. So you think about it, Iteration 1's like, yeah, admins can sign up, create a quiz, play with the quiz's name or something. Iteration 2 was a lot of like quiz questions and like duplicating a quiz and a question, sorry, right? Like lots of setting up the quiz to be played. Whereas Iteration 3 is all about playing the quiz. It's all like, okay, you've created the quiz in Iteration 2, you've got questions in it. Now how do we have someone click a play button where they can now then go and actually like have other people come into the website and answer questions and whatnot. So that's the crux of what Iteration 3 is about, just at a high level so that you can get ahead of that. But our point is here, what we're saying with this stuff is that you can actually largely copy and paste the routes from Iteration 2 to 3 and expect them to do kind of the same thing, except for these exceptions here, which we've like written out for you. This is just so that you don't have to spot the difference, you know? Because nothing's worse, like Swagger's not really a nice document to like scroll up and down between because it's so big, you know? Like, yeah, sure, you could get 2 windows up side by side and like look at them, but like that's not your job, right? So we've just outlined what that is. What you're doing in Iteration 3, the same thing as Iteration 2, largely. This is a summary, so we'll come back to that at the end, maybe. Running the service is the same. Implementing and testing features is the same. Test coverage. Here's a new section. We talked about coverage back in last week? Was that last week we talked about coverage? I feel like that was a year ago. Goodness gracious. So test coverage, what we're saying is in this iteration, you will be marked on test coverage. So we will, when we run, so I'm just trying to remember, when we run your tests against your, your tests against your code, we will try and see how well your tests cover all the code in your code. That'll be automatic because we just will run jest on your tests. That doesn't make sense to run it on our tests, does it? Because you're testing tests. Yeah. So the point is that your tests are a little bit more important to get right this time, because in iteration 2, realistically, you could just have one test to test auth register and get like full marks in the auto marks, right? If your implementation was good enough. You get screwed in the other marking, but the auto mark, there was no inhibitor to that. Whereas for iteration 3, you can't get away with writing one test and then just multiplying that by perfect code. So bad test, but amazingly correct code doesn't guarantee full marks here. You also need to show that your tests are amazing as well. Thankfully, because a lot of you have been following good testing practices throughout iteration 2, you're probably in a good spot. This section here, 5.5, planning for the next problem to solve. This is actually quite a big section. What it relates to, if I just jot down to the marking criteria quickly, is a 15% part of iteration 3 that comes down to writing a bit of a document together. That will involve a little bit of conceptual modeling, but mostly it's related to work UChow teaches in week 9. So I'm going to leave that one to UChow to circle back on, if that makes sense. You can go read it. There's nothing kind of super complicated about it, but it does relate to week 9's lectures. So UChow will talk about 5.5, but for now, just imagine it as a black box of kind of like a planning document job. That's 15% of the iteration. That's the only thing I'm not going to be talking about today, because everything else we've covered. This little section here, 5.6, states and actions. Basically, this is also not anything new, except if you go to like the Swagger docs, you'll see that for iteration 3, because you're playing the game now, your software is actually starting to behave like a state machine. Because if you think about a Kahoot and how a Kahoot works, right? The game starts, everyone joins, you're in the waiting room, someone clicks play, first question, countdown, 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 question's done, see the results, new question, you know? Like you could probably draw this out now after we talked about the previous lecture. And what you'll see is in the Swagger docs of these new routes, you'll see things here like state lobby, as in the current state of this particular session of a quiz is lobby state, you know, because you're in the lobby waiting. And similarly, someone can update the state of, an admin can update the state of the quiz, like say, go next question, skip, go straight to the results, right? Just like an admin can in Kahoot. And in those cases, they pass in an action here. Now, all of the actions that you can use are documented inside the Swagger, right? However, because it's a little hard to find, it's a little bit not obvious, even though it's right there in front of you, we did also include a list of it with elaborations in the spec. So all this information is just elaborating on what's in the Swagger, just so it's a bit quicker to digest and see. Because otherwise we would just have to give you this list here, which I think you could probably make some sense of, but it's a little bit hard. And then we backed that up by adding, yes, a Miro diagram that I drew a long time ago here, which is a state diagram for it as well. I'm not going to say that it's the most impressive layout that you've ever seen. It's always upsetting to see lines cross. You know, no one likes a good line crossing in a diagram, but that does explain it for you too. You do not need to request access to edit this diagram. Every term, I get about 6 emails from students who try and sign up to Miro to get editor permissions to the diagram. I don't know why, but I delete those emails like clockwork, so you don't need to do that. Yeah, so there's the states. That's just part of the functionality of iteration 3. If I'm talking about Kahoot and these like lobbies and stuff and you're getting confused, I would really go and play the Kahoot, but I'm pretty sure again that I'd put that in the iteration 1 video those terms ago as well. So yeah, most of you should be familiar. Error raising, I'm going to come back to that one because that one's a bit more involved. I'm going to come back to that one because that one's a bit more involved. 5.9 deployment. We would like you to deploy your repo to the internet. Now, just to be clear, when we say deploy your repo, we are talking about your, sorry, my brain. We are talking about your like server, not the front end. And I think this is really important because, like, obviously we as a course have deployed a sample solution, which who's played around with the sample front end and all that? Yeah, it's like a lot of you. We deployed both the front end and the back end. Both the front end and the back end are running up on the cloud somewhere. For iteration 3, we don't expect you to deploy the front end. We just expect you to deploy the back end. So what that means is, like, let's imagine you and your group of 3 want to play Kahoot together. Yeah, after you deploy it successfully, what you should be all able to do is run the front ends locally on your laptop, right? But you can configure the front end to use the server URL of something like a website, like up in the cloud. So basically, you would have 3 front ends running on a local machine. They'd all be talking to something up in the cloud that you've deployed. So in theory, at the end of this course, your aim should be that you can play Kahoot together. That'd be fun. You could play your little Kahoot game, start a game up, see who wins. Maybe the 4th group member can create it and run it, and the other 3 of you can see who wins or something like that. So that's what the deployment part is. There is a Lab 9 deploy that you've probably seen this week. That helps you deploy a particular lab. So you can employ what you've learned in Lab 9 deploy to go and get it working for your project as well. It is normal for only one group member to do this, just because, like, only one person can deploy, you know? So I don't want people scared about that for unequal contributions. And no tutor's going to be like, if you say to your tutor, I wrote no code this iteration, but I deployed it, they're going to be like, no, that's not okay. So it's something where, like, you know, deployment might mean that you maybe do like 10 or 20% less coding than someone else if you're really, like, anal about trying to get everything balanced. But generally speaking, I would really recommend with deployment that you pair program that one. It's following a lot of instructions. Lab 9 deploy is quite an elaborate lab. It's not hard, but it's long. It's a lot like the Git setup. Remember Lab 1? And you know what happens? Remember what happened in Lab 1? If you did one little thing wrong or you missed a step, a couple of you probably did that. Like, you end up, nothing's working. And you're going to have the same experience here largely. So I think it is really useful to do it at least with someone else beside you who's, like, following it, because you miss one detail and it can all go pretty badly. And as I've said before, don't go and pay for anything. Everything we've done doesn't require a credit card. If you see yourself punching in a credit card into a website somewhere, stop. Yeah, it's not necessary. 5.10 and 5.11, these two things are similar to this section up here with the states and the actions, in that 5.10 and 5.11 just help elaborate on the behavior of the software for iteration 3. In particular, if you look at the Swagger, some of the last routes here are like, when the game ends, you should be able to get a bunch of results like this. Like, here's the users ranked by the score. Here's all the individual question results. This question, these players got it correct. The average answer time was that. The players correct, you know, percent correct is that. This section here is just so that we don't have to shove something again deep in the Swagger where you're going to miss it. We could put that in the Swagger. We could also put this one here, 5.11 in the Swagger, because there's also another route under that, above that. Where is it? Am I losing my mind? Oh, there it is. Sorry. Oh, yeah, okay, sure. Sorry. So these routes down here, all these player routes are for, like, this is what the routes, like, you got to imagine an admin creates a Kahoot and then shares the link with a bunch of players. And the players, when the players are talking to the server, they're calling it through the player routes, whereas all these admin routes are still the person who's managing the server. So there is another one here called, you know, CSV, where you actually are meant to return a file path to a CSV. So you have to create a CSV, a comma-separated file, comma-separated value file. You save it to your server. You return a link to that file. That's what the route does in that case. And again, this has been elaborated on here. Like, if I was to explain this to you, I would just read it out word for word. So this is the kind of thing that's like, I'm just contextualizing what you're looking at. You can read it because the instructions are there, and we try and make sure it's quite thorough. What you will notice again about this iteration is that it does lean itself pretty well towards breaking things up. Like to update a thumbnail for a quiz is kind of unrelated to stuff. The sessions and the session starting like is a little bit blocking, but then like getting the results someone could do after somewhat independently. The player joining to a session can be sort of done independently, but like anything, you can sit down as a group and figure out what should we do first. Like I think for me, it's pretty obvious here that the first thing you should do is probably starting a session, you know, because like once you can do start session there, you unblock everyone else from being able to modify the session or maybe get the results. That might take a little longer, or they can actually start doing this player stuff as well, because you'll see that for a player to join a session, they need a session ID. So it's like you as a group, and I'm like just giving you a big hint here, but I would trust you could all figure this out too. You should sit down and look at this stuff. You know what? Draw a little diagram. It's a great thing. What depends on what? You ever done that? Did you do that in iteration 2? Some of you did? Amazing. See? You're geniuses already. You don't need me. So you go and do that. You figure out that's the starting point. Get that done first. Work on everything else later. Yes. Your iteration 3 has a final presentation. Yuchao should have explained this to you clearly already. You've probably already picked a time slot on the course website. I can see all of your time slots already. And yeah, you just have to turn up in week 11 at that time and do it. I'm not running it this year. I ran the course last term. It was something I introduced. So I probably can't answer a lot of questions about that this term, because again, I just don't have a lot to do with the organization of it. But what I'll tell you is that it was pretty smooth. You turn up as a group at the time. You do the things that the tutor asks you to. They ask a few questions and then you go, and then you're good. I wouldn't stress too deeply about it, because it's not like the end of the world, unless you just don't turn up. That's not good. If you just like decide to never appear, that would suck. Got a few questions. I'm just going to get through the criteria quickly and a few other things. This iteration, 60% auto marking, 15% magical. Yuchao talks about stuff next week. 5% code quality, 10% Git project. So a lot of this is just, you know, more auto marking, less on the fluffy stuff. 10% of marks come from showing that it does work with the front end and that you can get it deployed. So this is like just 2 features of that 10%. And then there is a bonus marks up for grabs for 10% if you can get all of your code totally type compliant based on those rules. Yes?
So these bonus marks, will just come out in iteration 3, or can they have a makeup for iteration 2 and 1?
So the bonus marks will increase your iteration 3 mark, right? However, if your iteration 3 mark goes above 100%, that'll flow into the other iterations. Yes. So if you follow these instructions, add this to your ESLint-RC file. When you run npm run tsc, you will potentially get errors. Basically, the current tsc command from memory, if you say like, you know, const blah equals foo any, the current tsc command I think will pass that for you, or the lint command or whatever. Like this will be okay. The extra rule that we get you to add in, if you want the bonus marks, will stop this from working. You basically can't use any. Yeah, because the TSC has a rule called no implicit any, which says that you can't not define it. Like if you want to use any, you have to explicitly say any. Whereas this rule says no explicit any either. And it's like, no, every type should be clearly the right type, and you can't use any as a way to cheat out of it. I don't know the exact numbers of how many groups did this last term. I'm trying to remember. I think it was about 1 in 2 groups did it, which is probably a good indicator for you. If you feel like your group's in the bottom half of the course, maybe stay away from it for a while at least. And if you feel like your group's in the top half of the course, or especially the top part of the course, then I would probably jump in it early, because like the tighter your TypeScript is, it'll also help you find bugs, you know? Like there's a fixed amount of time you have to spend getting types working. So if you can do that early as opposed to late, you end up using the same amount of time, but the earlier you do it, the more likely you are to uncover other issues, which will speed up your life in general. It's another great thing to do if someone's kind of like a little blocked, like if you say, you know, you want to get started tomorrow and you know you got to get a few things done before everyone has a lot of work to do, you can just get started on things like TypeScript or deployment. You should be able to deploy your project now. You don't have to wait till you're done iteration 3. Sure, it won't all work, but like nothing stops you deploying it either. In terms of the mark, I made a rough allusion to this. It's kind of calculated here. This is just a formula for coverage in this particular case. You can kind of unpack that in your own time, but it's basically saying like good coverage will mean that you get full marks for that. If you don't have good coverage, then it means that it's bad. I think this formula has been changed this term. I haven't really been told much about it, so I can only answer so many questions about it, but it's all generally the same principle. Coverage is now part of the marking criteria. We have a dry run, and we have a due date, and we have peer assessment, and they're kind of some of the main things. This mouse, if everyone can see, it's just being real glitchy. I don't know what's wrong with this stupid computer. I can't click on anything. Okay. So can we just follow the Swagger and finish every function on it, then works will be done? I guess so. I mean, you'll do relatively well in the correctness part of the auto marking. But yeah, I mean, if you want to ask if I just do the Swagger, will everything work okay? I mean, the auto marks are 60% of the marks, and the auto mark you get from our marker is multiplied by stuff to do with your tests, you know? So you couldn't just do the Swagger. That would maybe, you know, get you part of the way. So you probably can't think about it quite that tight. Do we need to write tests for iteration 2 modified routes even if we be calling the same function, v1 and v2? Yes, but thankfully you can copy and paste those. I'll get to that too. Let me add a note to that. Wait, did I delete my stuff? Yep. v1, v2. Do player sessions match whatever the quiz session is? Think of player sessions as like, you know, in iteration 2 you had a user and a user had sessions. Iteration 3, quizzes exist and quizzes have sessions, you know. It's like it's basically saying that if you have a game and a game's like a template and you can start a version of a game, you know, because what happens if you're running a school, right, and you've got a great quiz and you've got 3 Year 4 classes, you know, and you all want them to play the Kahoot in their own separate classes and not together. You need to create 3 sessions of that singular quiz. For the thumbnail route, it says it's updating the thumbnail. Is it also adding the thumbnail if there isn't already one? I don't know. I don't actually run a lot of that level of detail with the spec. Because I did write this now like a year and a bit ago, but every term they make like slight adjustments to it. You know, like students have problems and they tweak this and tweak that. So I don't want to answer a question that granular. That's a good one for the forum, just because there's a more than 1% chance I'll give you the wrong answer. So they're the questions so far. So now if we go back to, firstly, let me talk about this whole V1, V2 thing. So the reason this was introduced is because, again, we talked about this back in week 4. In reality, when someone introduces a updated version of logout, right, they don't just delete the old route or overwrite it. They need to support both at the same time. Because like other people are still using your old logout route, you know? You're a company and you're providing a service and people are using it. So you've got a new one over here and you would like them to get off it in the next few years, but for a while you need to support both. So we do actually want you to have both. And in the scenario where you have both, it's not super unreasonable a lot of the time to copy and paste. Like you're just going to copy and paste the route, you know, because like you've got a separate route with a separate URL. The degree to which it's reasonable to have, you know, duplicated code or not is kind of up to your discretion to some extent to do your best judgment with. But the question about tests, yes, you will need to duplicate your tests, but that's okay. Testing is inherently a bit of a messy copy and paste topic a lot of the time. Like a lot of tests are actually people copying and paste. Like you've probably seen this with usernames and passwords, that you copy and paste, you change the values. You could probably wrap it in a really complicated for loop with arrays and stuff, but we don't want to do that. We need to keep it really simple. So that's just on that part. What exactly is different about the V2 routes we will get to, because that is one of the things we need to chat about. Someone says, how should implementing chatting be approached? I mean, I don't know how to answer that effectively. Like, as in, that's kind of your job to figure out. I could probably answer a slightly more targeted question if someone's like, I'm trying to use this, will that work, or will there be any problems with it? Brendan says, are timers going to be used for the project? That's on the YouTube. That's a great question. There is a tiny bit. There's very little. We've kept it to be quite small. But there will be a part of the project that uses JavaScript's set timeout feature. You haven't dealt much with this, and I'm not going to talk about it in really much depth at all, because it is something that I think falls in the realm of you should be able to tinker with it and get comfortable with it. Has anyone used this for anything so far? A couple of people. It's really quite a straightforward thing. This makes it look scary, but at its core, it's a function in JavaScript where you pass it in a function and then you give it a time in the future to call it. It's a deferred function call function. So instead of you call a function, what you do is you call set timeout and you say, instead of calling this function now, I want to call it in 3 seconds from now. That's all it does. It's quite straightforward. You don't actually need much more than that here, as far as I know, again, unless something has changed. There's one small part of the project I think you need it for, and the other part, if I'm not mistaken, is that the project has been written in a way that if you don't actually ever get around to it, you can actually skip that tiny part of the project and you barely lose any marks anyway. So I don't want anyone to feel like that's a blocker or that's a stressful part of things at all. Now let me go back to 5.7 and 5.8. Let me start with 5.8 because this one should be pretty easy. Part of iteration 3 is about creating safer user sessions and secure passwords. Cool thing about this is that I explained a lot of this to you on Monday. We spent a lot of time together. First part is we expect you to secure your passwords for iteration 3. That means we expect you to hash your passwords. It's pretty easy thing to tick. Your tutors will be looking for that. The other one is we ask you to create more random user session IDs. Now, this summarizes also what I said, which is that your user IDs should be unpredictable at minimum. However, that doesn't make them totally tamper-proof. What makes them tamper-proof is doing something like the signature that we also talked about on Monday, which you can also look into if you'd like. It's something that, as I've said, you don't have to do that. You just have to make sure your user IDs are somewhat more random. However, I would encourage you to try that out. I think it's like, saying something's important doesn't really motivate people to do it that much, but I do think that one is quite interesting. And there'll probably be someone in your group that cares. So 5.8.1 and 5.8.2 are just saying do what we taught on Monday. 5.8.3 though is a little bit more involved. So everyone remember back in week 4 how we talked about how for get and delete requests you send things over the query, right? It's what you've been doing for a few weeks, so I assume you remember it. You don't have a body for get and delete requests. Does everyone also remember how in week 4 we talked about how everything you send in the URL is clear as day for everyone who intercepts it and everything in the body's encrypted? Cool. Has anyone had a moment where you're sitting there thinking during iteration 2 that we're sending a lot of tokens and secure information over the URL as the query for get and delete requests? There's a lot of sensitive stuff out there, because if I get your token, I can imitate you. Like, I don't remember if I showed you this. I think I did. I did on Monday. This course website. The thing that logs me in is this thing here called Eccles JWT. I'm not going to show you the whole thing, but never mind. Now I have to log out and log back in again. Someone will bloody copy and paste that. But point is, if someone could really quickly right now copy and paste that into your one, right? before I hit that logout button and invalidate the session, which you all get that now because the session's now gone, you could be me. Because all the browser's doing every time a page is loaded is sending that thing, that token back to the server. So that token in a way is like a password, you know? It's quite important. This is also why we make sure it's not tamper-proof. Okay, so just to clarify, if you took my token and put it into your computer, because you can edit these fields if you'd like to, you could be me. But because it's a tamper-proof token, you couldn't use it to modify it to try and be someone else, you know, because of that whole signature thing we talked about on Monday. But if you got it, you could still use it. So like if your friend leaves you their laptop open or something, you could literally open up, and don't do it, you could literally open up Instagram, find some random token, copy and paste it into your computer, and then you refresh your Instagram page and you're now logged in as them. Because that's all the information they have. It's not always stored here, it's stored in different places, and it can be much more complicated than that. But the point is, tokens are important, so we don't like to send them over the URL. Sending a GET request as like a token in a query string is a terrible idea. It's disastrous, in fact. So to get around that, and how everyone else does it, is they don't actually send a token through the URL. And they don't send it through the body in GET requests because you don't have a body in a GET request. So where they do send it is this other part of the request called a header. And a header contains a bunch of random information. It's basically the metadata of the request. It contains things like what type of content am I sending you? Am I sending you an image or text or code or whatever else, or JSON? And what it means is that in our code, instead of in our server, and again, I'm trying to give you the gist of it without telling you exactly what, because there are instructions here, is like if you maybe have a route that says like app.get, you know, v2 blah blah like this, request response like that, you currently might have something that says like const token equals request.query.token like that. What we're saying is that you need to change your approach to, instead of doing that, you need to use this instead. Now, then the next question is, well, how in the world do I send that over the header? You know, when I send a request, just let me just quickly find the code. I normally have it up, but again, I'm on this loaner laptop at the moment, so my life is quite challenging. It's not really challenging, that's a bit dramatic. Where am I? Testing? Working with just... Oh, yeah. So if we look at this piece of code here, in particular this part, and you should, again, be familiar with this because this is kind of, you know, iteration 2 stuff. You're like, okay, well, I make a request. Look it up. Again, I'd like to challenge you to have to look stuff up yourself, but next to the query string or the body, because, you know, in some requests there's a body, there's just another parameter out there called header or headers, I think. I can't remember if it's headers or headers, but there you'll be able to add token, blah, 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 like that, you know? That's just it. So instead of it sending through the query string or the body, like you're doing in iteration 2, you just have to send it as a header. Now, all the headers of a request are encrypted. That's why we send it through a header. What this means is that for most of your iteration 3 modified routes, the only difference between the v2 and the v1 versions largely is going to be how the token is handled. That's the main difference. The other differences are very rapidly summarized at the top of this iteration 3 section here for you. But besides these changes here, the only difference is that the token is now handled through the header, and that is a fairly trivial change. It is also why you will need to, you know, naturally copy and paste your tests to make sure that, like, you know, like, because if you copy and paste your test, the tests will look the same. They'll just change how the data's passed through. It's hard with testing sometimes. Sometimes we want to not copy and paste it. We want to super abstract it. But with testing, it's so important that our tests are really clear, you know? Too much abstraction in testing can, like, make our code ugly. In fact, like, I would rarely abstract my tests more than this here. Because, like, you want someone to be able to, like, literally understand it. The general rule of tests are, like, They should generally not call too many like nested functions, and they should avoid loops wherever they can. It's okay. It's kind of funny that it's a little bit different to normal code, because normal code we want to really focus on never repeating ourselves, and we're happy to make the code a little bit more complicated in exchange for a little loss of clarity, in exchange for kind of I don't know how to put it, more robustness, I guess. Where am I clicking? Here I am. So that's what 5.8 is about.
So changing the token headers, is that just for the V2 functions? We don't need to change the V1 stuff from iteration 2?
Correct, yeah. And yes, and I'm glad you mentioned that, because what this brings up is that part of our testing, our auto marking for iteration 3, will actually call all of your iteration 2 routes. So imagine that the iteration 3 auto marker is actually 20% just the iteration 2 auto marker. If that makes sense. Calling the iteration 2 routes that you've already done. And the other 80% is those new routes we've got, the new 2 sections. The reason we do that as well is because we're really trying to emphasize the importance of having your code be fully robust in the midst of establishing new parts to it, Like all of your old stuff still needs to work fine. But again, behind the scenes, it's not going to be too bad, because you're going to have like a V1 auth register, admin auth register, like in your, say, server.ts, right? Maybe that's not the best example. Maybe like an admin quiz. You'll have like your get admin quiz, and which is like your iteration 2 one. And all that's going to do is be like, yep, const token equals request.query.token, and then it's going to be called like admin quiz get or something like that, pass in some stuff to it, and it's going to do some whatever, return some stuff. And then what you do is for iteration 3, you're able to kind of copy and paste that. It's a V2 route now, and instead of you capturing it through the query, you capture it through the header, and now you've got 2 routes, but they still call, because what they do after they dissect the HTTP part there is they call the exact same function, which has the same functionality. You as a programmer would be like, well, I shouldn't copy and paste admin quiz get, because some people out there might make like an iteration 2 function and an iteration 3 function or something and copy and paste them. But why would you? They're the same thing right now. They literally perform the same behavior. So it makes no sense to separate that out or duplicate that. So, a lot of this project has, in a good way, tried to evolve in the direction of making you think a lot about complex software and how to structure it and manage it. So hopefully that sends you down that path as well. The last thing is a new section that's been added this term, which is also, of a similar principle of trying to improve your software development. It's to do with errors being raised. So in week 5, Yu Chao taught you exceptions, I believe. In this iteration, this one isn't actually too bad. What we would like you to do is, if you have a function like a admin quiz get or whatever in quiz.ts, right now that function probably does some stuff, and if there's a problem, it probably does something like return error, there was a problem, right? Like you do like an early return with an object that contains an error key in it. For iteration 3, we're asking that you refactor your code. This is all going to be manually checked because it shouldn't change your code's behavior. You refactor it to, instead of returning stuff, we want you to throw, I can't remember, oh my God, my JavaScript throw exception. I'm not sure if new's there. I look at like 4 different languages a week, so sometimes throw new error. Okay. I was about to write throw new exception. I was about to do that, and I was like, is new meant to be there? But that wasn't the problem. It's not exception. I teach C++ this term mostly. That's my main course I'm teaching. So it's like my brain's all over the place. Throw new error, there was a problem. So instead of like returning an object with error in it and then checking if in the server if the returned object contains an error key, you're simply going to be wrapping your function calls in the server in a try-catch and throwing exceptions in your underlying functions, if that makes sense. That in itself is actually not terrible, and in some ways it'll actually make your code easier to read because you don't have to deal with all the weird return cases and stuff, because it's just you throw the exception and the function's going to end. But there are two rules that are really important that we want you to follow for iteration 3. And many of you will maybe have been following them already, and some of you haven't been. The spec has an attempt to describe this in some detail, though I'm going to describe it for you, I guess, in my own ways, which is that outside of server.ts, there should be no reference to 400, 401, or 403. And the other rule is that server.ts routes should never, ever, ever pass in request or response into a subsequent function. Now, an example of this one being violated, this first one, would be if maybe I should make that more dramatic. Let's make that more dramatic. Yeah. Drama. Okay. ASCII art. So in this first case here, an example would be if I have a server.ts file and I've got my app.get, v1 blah, request, response, and what I do is that when I call admin auth register, one of the things that I passed into it might be a response object. And I do that, so in my auth.ts, in my admin auth register function, when I take in my response, I can be really lazy and just say, you know what, response.json error. Like basically rather than have to send the error back up and then, response dot, status 400 or whatever. I don't think many of you would do that because your iteration 0 and 1 routes were so well prescribed, you've probably never changed what they take in, just out of habit, most of you. So that's not really a concern. This second part, though, is slightly more interesting. For some groups, won't be a lot of thinking, and for other groups, depending on how you've done stuff, might be a lot of thinking, which is that we don't want to see any reference inside files like auth.ts or quiz.ts to 400, 401, 403 errors. What that means in those cases is if you've got this admin auth register function, what we don't want to see is people say, if there's a problem there, returning something, for instance, that says like error, user already registered, status 400. Does anyone do that currently? Okay, interesting. Good. So let me just quickly explain to you. So the reason that we want to steer you away from that is because one principle that's always really important in software is separation of concerns. Which is like your server file is essentially something concerned with reading HTTP requests and making responses. And it generally has, and it should have very little to understand about how the Kahoot actually works. It doesn't really know much about quizzes or what a quiz is or what a state is or what an action is. It's just kind of this like nearly translator from HTTP land to JavaScript land, right? And it kind of protects your app from like bad tokens and things like that. Similarly, your auth.ts and your quiz.ts, sometimes we refer to these files as application logic or business logic. And that means it's the logic that is actually specific to that app you're trying to build, right? Like if you think about it, you're making an application or a business, it does that for you. It really doesn't need to know much or do anything about HTTP stuff either, because it's not relating to that. That's good function design in code. That's good separation, where you have stuff not having to know what everyone else is doing. So part of that is figuring out a way where you can, generally speaking, not have references to HTTP-like stuff in functions that don't give a crap where they're being used. Because if you're not sure what I mean, once you start throwing HTTP statuses in these functions, to put them in there, now this function is forever implied that it's for use on the web servers, But what happens if someone wants to use it somewhere else, like say iteration 1 or somewhere where there's no HTTP server, right? The function shouldn't care about where it's being used. It should focus on its job and not really much more than that. I know we only have 5 minutes left, so I will unpack that with a slight more example, but I want to get to a question or two.
If we throw the errors inside the functions themselves, then how would we know which status code to return the server up?
That's the question. Well, that was all I was going to talk about anyway, so that works really well. Thank you. The short answer And I'm not saying that this rule would apply all the time, every day in bigger projects, but in the context of this project, the cool thing is that there's only 3 status codes that you generally throw, right? And one of the better parts is that a status 401 and 403, they often relate quite heavily to, particularly 401, relate quite heavily to a token specifically. And how a lot of you have probably done your iteration 2 code is you've come along and you've said like, well, you've got 3 steps here, which is I'm going to fetch the data from request, I'm going to call a function, get the return, and then I'm going to respond with JSON. And you probably have like a really tight little file there. What you then probably find is that as you have your admin auth register here, I bet in many cases your admin auth register is taking in a token, right? Put your hand up if your admin auth register is taking in a token. Right, well, let's think about it for a second. Does admin auth register really need to understand a token, which is basically a form of like HTTP communication? You know, like it's a way of packaging up information inside HTTP. It probably doesn't. So you know what? Probably before admin auth register, you should have a way to extract that up here, or say like, you know, check user from token, which might take in the token and return, say, user ID or something like that. You know, outside of that admin auth register function, so that when you actually, what you actually pass into admin auth register is itself a user ID. Because like the point is, admin auth register, quiz, and all that, they shouldn't really be decoding HTTP tokens, you know, to do with JWTs. That's all about authentication and whatnot, and you can separate that out. So, I mean, that's just one example of how to do it, but the really short answer with this to your question is like, a lot of where this feels painful is because a lot of groups will converge themselves into like, each route calls one function which does everything for me. But it's actually okay to maybe call a couple of functions in your routes that do separate things. And quite often what you'll find is this can actually clean up your code a bit, because, you know, decoding a token and figuring out if someone's logged in, why should that have anything to do with the quiz create, quiz get, quiz modify? Those functions should be concerned with just modifying the quiz, not making sure anyone's even allowed to. You know, like if you get to a point where you're calling a quiz modify function, there probably should be a separate function that was called beforehand that checked if you should even get that far. So the purpose of that rule is mostly to make you think about your software in a slightly more separated way, because without that rule, it's very easy to fall into that trap of I've just got a big function that does everything. I hope that was helpful. Yeah, cool. Yes?
So are you essentially saying just do your error checks in the route, basically?
What I would probably say more colloquially, and this is the first time we've introduced this, so like my communication skills will be the weakest on this naturally, because first time I've ever said this to people in a course. But what I would say is like, me quoting myself, generally a function should probably generally a function, if it has potential errors, should probably only be related to one type of error. That's probably what I'd say. As in like, if you're calling a function and it goes wrong, you should probably be like, if it's gone wrong, that function going wrong means that it was a 403. And if I called that function and it went wrong, it's probably a 400. And if I called that function and it went wrong, it's a 401. It's probably harder in the real world. It's actually really easy in the project, because like if you think about it, you simply like decode the token, and if the token's invalid, it's a 401, easy. And then you check like, is this person who, you know, they permission to do this, which might be a bit more fiddly. That's one check, and that's a 403, right? And any other error you experience after that's a 400. Because once you've verified the token's valid and you know who they are, any other problem you see is just a 400. And that actually makes this project a really easy place to do that. In reality, it probably does get a bit more nuanced and complicated with what all this means. So I don't want anyone to like, again, I always have this fear of like people ending up in the workforce. Because you'd be surprised, a bunch of 1531 students, they hunt me down. Like my startup, we build an app really like quickly. We're a startup, we're building stuff quickly. So we actually don't do a lot of what we teach in this course. And I got a student like email me like 2 years ago. They were like, I did 1531 with you in 2019 and you instilled into me the importance of testing. And I used your app the other day and it was buggy. And all my inspirations about, you know, software correctness are like gone, and you've disappointed me and stuff. So what I don't want is like random stuff, like you get into the workplace and you're like, some random dude was like, I cannot mention the word 400 outside of a file, and then they're just going to be like, what? So don't take that to literal gospel. It's just a great rule for this project to get you thinking about separating things out that you probably aren't separating out at the moment. Really quick, there was a question, how do you write a header when requesting for the server stuff, etc.? I did kind of cover that like 10 minutes ago. That was when we pulled up this stuff and I wrote a little bit of code here. I said go look it up specifically, but it's a really quick, easy thing to Google. Actually ChatGPT is also really, really smart. I guarantee you if you took one of your test files, pasted it into ChatGPT and said, I need to add a header here called token, it would just give you the code again. And that's a great example again of how LLMs can help you actually learn something quickly without kind of, you know, plagiarizing the whole thing. So you could try that out if you want to. But any other questions, shoot them to the forum. Otherwise, thank you, and I'll see you all in week 10, probably online. But yeah, thank you.